All right, cool. Let's do part C calculations. Ruben, again, the mask and the phone. All right, so we are looking at part C of the calculations. What you guys might notice that I mentioned in the previous lessons was making sure that you write down what you're doing as your accuracy improving technique. The reason why I want you guys to jot those things down when you're working is so that way when you guys do part D, you then can reference it and you know what you did during the practical. So you remember, oh yeah, I rinsed my equipment and I checked for no air bubbles and I removed my funnel. So this is to help you guys just recall for part D, and I'll write that down on this piece of paper so you know why you're doing that. I'll talk about part D in more detail later because I don't want to overwhelm you, but just as a general thing to keep in mind is that for part D, for the achieved, I need 2 accuracy improving techniques. So you got to tell me 2 things you did to make sure you did a good experiment. So basically any of these 2 out of the 8 that I've listed are fine. That's what you need to do for the achieved. So that's why it's really important that you write this stuff down so that way when you go to part D, you know what you did. If you are aiming for a merit, I need you to tell me how these techniques improved your accuracy. So giving me an explanation to why you rinse your flask with water, your pipette with acid, and your burette with base. Are we okay so far? All right. If you're aiming for excellence, you need the merit requirement. And the other thing you need to think about is making sure you have that depth in the reason to why. So for example, if we wanted to explain why we are rinsing our equipment, you would say, I'm rinsing my equipment to remove any potential contaminants, right? The other reason why we're rinsing our equipment is first, like specifics. For the pipette, I am rinsing it with acid instead of water because if I rinse it with water to remove contaminants, there's going to be leftover water droplets, and those leftover water droplets could dilute my acid when I do the actual experiment. And if I dilute the acid, then I won't correctly measure the concentration of the acid. I will underestimate it. Does that make sense to everybody?
Yeah.
So you got to be explaining the why behind it. Same thing with your burette. We're rinsing it with the base instead of the water because I don't want to dilute any of my base. If I dilute any of my base, then I am potentially overestimating the amount of acid is there. So basically it just means your calculations will be wrong. So have a think about each one of them. Remember, I have come around and I have talked about why we're doing each one of these techniques in our earlier lessons about titration and those mistakes. I also have said this multiple times when I walked around and looked at what you were doing. I've constantly said, remove the funnel, if you guys remember, because we're mindful that if the funnel drops extra liquid after you read the burette, you're then not going to accurately read the titrate volume. So you're then not going to be able to calculate the acid concentration properly. Are we okay with that so far? Mm-hmm. Are there any on this list that you want me to explain why we need to do them for the accuracy? Mm-hmm. Are we okay?
Yes.
We good? Do some math? Okay. So here is the data that we are looking at. So I did this experiment as well. And what I did was the exact same solutions. I did my own titration. And when I did my titration, these are the values that I got, and this is the average that I got. So I want you guys to take a moment and copy down my numbers, so that way on the teaching example, you have the same numbers when we're doing the calculation. So copy these numbers down. All right, so this is what I got from my data. I made sure I did 5 trials just because I wanted to be like really confident with my numbers and what I was getting. Something I want you guys to note when you're writing down your data is to write to 2 decimal places. And that's because when you're reading the burette, you can estimate to 2 decimal places. If my meniscus was on the line, then it ends in a 0. And if my meniscus was between 2 lines, I ended the number in 5. Just to say it was between those 2 numbers. So this one here was between 0.6 and 0.7. Are we okay with that so far? Yes? Right, the first one is my rough titration, because it's just to give me a ballpark idea of where things are. You will most likely be excluding that from your data set because it is a rough titration. But if the data's good, you can keep it. Again, just like with part B, you are looking at your highest and lowest value and you're eliminating things. This here, that 26.9 was my highest value. And I subtract away the lowest value, which is 25.45, just to see if I could use that. And I can't because the range is 1.45. So that's way too big. So I've excluded this data because realistically speaking, if I'm checking from the high point to the low point, this one's probably going to have to come out. It's just like what you guys did in biology, removing outliers.
Yes.
Right, so if I remove that one, my next highest number is that 25.75. And if I subtract away my lowest number, that's 25.45, I get 0.3. So that is within an acceptable range because the range has to be within 0.3 for me to be happy. Are we okay with that so far? This is all stuff that you guys have done before. I'm just grabbing the thing. All right. The good news is if you are just aiming for an achieved, you don't have to worry about doing this. But if you're aiming for merit or excellence, you need to double check this. While you guys are titrating, you can check this while you're working. So you know whether or not you need to do an additional titration. So most of you guys should only need to do 4, the rough, and then 3 good trials. If you check those 3 trials, and you can also use your first trial if the data's good, and if they're not within 0.3, do a 5th titration. If they are within 0.3, then you don't need to do the 5th titration. I did the 5th titration just because I wanted to make sure I knew what the number was, okay? Because we know the more data I have, the more accurate it'll be. All right, the next thing I then did was calculate my average. Make sure you're showing your work. Don't be lazy like me. I was just trying to quickly figure out what the number was that I was looking for you guys. So show that you're doing that 25.75 plus 25.75 plus 25.65 plus 25.45. So I'm averaging 4 numbers together. I'm dividing it by 4. Be really careful when you're averaging not to make a calculator error. We don't want to just divide the last number. We want to divide all the numbers. Does that make sense? So if your average number looks way bigger than your titration volumes, you've made a very big mistake. Okay? In this one, I want 3 significant figures and units, so this is what I got my answer to be. If I was to do 3 significant figures, that's 1, 2, 3, and I'm using this as my final number. I check the number next door. If it's 5 or above, I round up to 7. If it's less than 5, then I just drop the remaining numbers and go down to 6. Are we good so far? Joy. Oh, is it frozen? Thank you. My goodness. All right, are we okay with that so far?
Oh my God.
Yeah, sorry. All right, so this is my answer. Remember, 3 significant figures, 1, 2, 3, and units. You need that for an excellence. So if you want, it's useful for me if you circle your answer because that way I know where your number is. To liters, no. You're going to need to convert it to liters when you do the next calculation. So I will accept the answer either way. Okay? I keep it like this so that way when I'm checking your numbers, I can see if you are within range. Okay. So I need to check this number for accuracy. So I will do all the titrations. So I'll do the teaching one, I'll do the practice one, and I'll do the actual assessment. And you guys are trying to get what I get. Okay? Now there is some flexibility, and that is the range that I would accept, and it needs to be plus or minus 0.4 milliliters from my answer. Okay? So what this means is that I will accept any answer from 25.3 to, I'm not good at mental math, 26.1. So that is what I'm accepting as answers. Now, the good news is I only need that if you're trying for merit or excellence. Okay? So you can check your numbers now or later, and you can see, are you within that range? If you're not within that range, you should be definitely coming in on Friday so you can practice your titration. Yes? I will allow you to do it in pairs, but the calculations need to be done by yourself. Okay? The other thing is when you guys are working in pairs, I need to see both of you guys doing the titration. So it's not just one person that's doing all the data. Okay? And I'm making that allowance because of COVID. Okay? Good? Yes. Okay. All right, keep going. Cool. Calculations are very similar. I'm just working in a different direction. So next part, number 8, is I need to use what I got in question number 7 and figure out the moles of sodium hydroxide I used for that titration. So if you guys remember, we're using that concentration equals N divided by V equation to figure out my N. Now I need to rearrange this equation to figure out N. So N is equal to C times V. Now this value up here is my V. This value here, the sodium hydroxide concentration, or sorry, the concentration of the sodium hydroxide, that is my C. So I just got to plug in those numbers. Remember, we got to convert it into liters. Ruben.
Where does the 25.7 come from?
It comes from averaging my titration volumes.
Well, I thought the average was 25.65. Oh, rounded. Yeah.
Rounded. All right, keep going. Okay. So N is equal to my concentration, 0.1 moles per liter. I like to write down the units so that way I can double check my work and make sure I have everything in the right format. Since I see that this is per liter, I need to make sure that I convert this number into liters as well, right? So we divide by 1,000, which is 0.0257 liters. You don't need the parentheses. I don't know why I wrote the parentheses down. So that is my C, that is my V.
Oh, okay.
Okay? The liters and the liters will cancel out. Because that's per liter, and that leaves me left over with mole, which is what I want for my answer.
Oh my gosh.
That's why I write down units to make sure I know what I'm doing. All right, 0.0257 times 0.1. Here's my calculator. Push enter, and I get 0.00257 moles. At what, math? Yeah. At chemistry? I've had a lot of people tell me that I teach math better than their math teachers.
Yes.
All right, keep going. Keep going? Okay. So then I need to take this number here and I need to do my stoichiometry. So what we're looking at is those numbers in front of my acid and my base. what I can see here is there's no numbers in front. So that's a 1-to-1 ratio. That makes my life super, super easy, doesn't it? Because then I just copy down the number that I wrote before.
Wait, Miss, can I see the other one real quick?
The what?
The other one, the one that was in the file.
Yeah. Yeah.
Do you pick the biggest number?
It depends on what the ratio is saying. So when you guys are doing part B, it depends on if one is double or one is half.
You got it. Look.
Yeah.
Got it, dude. Look, dude. Got
Are you worried about part B now? Okay, should I show you what I mean by an example? So like, let me grab some more pens. So if the sodium hydroxide was 1 and the acid was 2, and I was trying to solve for the acid, I would need to multiply by 2. Because whatever this is the sodium hydroxide amount, so the acid amount would be twice as much.
You're so scaring me.
Does that make sense?
Miss.
This is not calculations. This is just me talking about what you do theoretically.
Miss,
No? Should I get back part B? Show you guys what I mean? Restarting.
On
Let me find B.
That's the left side.
You want me to go back to here?
Miss, when did this on the left side?
Yeah.
I was just scribbling stuff to show people something.
Miss, if there was a 2 on the
Yeah,
left
so
side,
is it 2 on the left side?
you like divided?
Huh?
You just swap around.
What am I doing?
I mean, it was like the ratio is like 2 to 1.
I'm just talking about the ratios. I'm going back to grab part B from the last one.
I guess think about the ratio.
Yo.
Here we go. Okay. I have grabbed part B, and I'm going to put part B on the screen, okay? That was the last one that we did. Because you guys were asking about ratios. All right. This one here, you see how there's no numbers in front? It's a 1-to-1 ratio. So what that means is I can just copy the answer from number 8 into number 9 because the ratio is the same. So how much acid I have is the same amount of base. Okay? So this part C, the acid amount is also 0.00257 moles. Because it's a 1-to-1 ratio.
Oh yeah, you're so right.
Okay? Can I go back to part B and show you part B and just talk about what happens when you don't have a 1-to-1 ratio? All right, this is part B. In this equation, you see how this is a 1-to-2 ratio. So for every 1 sulfuric acid, I have 2 sodium hydroxides. Now it depends on what I am asking you to solve for the equation. In this question, I was asking you to solve for the sodium hydroxide. So since I have 1 sulfuric acid, which is what I got from that number before, I needed to multiply it by 2 because I have twice as much base as acid. Okay? If I had asked you to solve for the acid instead of the base and we were working the other way around, you would be dividing by 2 because you have twice as much sodium hydroxide as you need for the acid. So it depends on what you're trying to calculate. So that's how you decide whether or not you're multiplying or dividing. It also depends on what numbers are in front. Okay? Brooklyn. If we had the different numbers swapped around and this had, oh, let me grab a different color. If this said 2 in front and that said a 1.
Yeah.
So since we are solving for the sodium hydroxide, for every 2 acids, I only need 1 base. So what I would be doing is I would be dividing it by 2. So you have to read the question and you have to see what they're trying to ask you to solve for. So like, for example, in this one, the first question, we were doing 1 to 2 because I was asking you to solve for the base, and you had the concentrate, or you had the amount of acid. If I had flipped the question around and I was asking you to solve for the acid, and I have given you the base, and these numbers were still the purple numbers, I would be dividing by 2. If the equation was different and it was the orange numbers, and I was going from acid to base, you would be dividing by 2 because it's twice as much acid. If I was going from base to acid, I would be multiplying by 2. So it depends on what the ratio is doing, and it depends on what you're solving for. Does that make sense?
Yes.
If I am nice, what I give you guys is a 1-to-1 ratio.
Please be nice.
Because if I give you a 1-to-1 ratio, there's no multiplying, there's no dividing, you just copy the number again. Okay?
Sorry if we were bullied.
Now you guys are all, I haven't marked part B yet, I'll mark part B. I'll let you guys know what your mark is, okay? The good news is you can still get married if you mucked up part B. All right. Keep going?
Yeah.
Gavin. I can't tell you because people haven't finished the assessment. Yeah. I'll mark it and I'll put the grades online at some point soon. Okay? All right. Last question here is we are now trying to figure out the concentration of my lactic acid that was in the, sour cream. So, again, you're using that C equals N divided by V equation. I have my N value here, and my V value comes from my instructions. So how much acid did we put in? What size pipette did you use? 10. So my V is 10. Or not 10, it's going to be 0.01. So that is where I got that number from. So concentration equals 0.00257 moles. Again, I like to write down my units to make sure I'm doing my math correctly. The volume is from that 10 milliliter pipette. I convert that into liters. And then I just do the division. So I get my concentration is equal to 0.257. I'm checking to see, do I have 3 significant figures? I do. So for my final answer, I would have concentration equals 0.25 moles per liter. And that's what I get for my excellence. You can write it there if you want. Don't really care. So now I know the concentration of my lactic acid in that purified sour cream. Isn't that cool? Know the concentration of one, figure out the concentration of the other. All right, let me pass out the marking schedule so you guys know what the Achieve Merit and Excellence criteria are.
I best of part.
I know you guys have already wanted to eat before, just marking schedule before, but I think it's been out again. And also I changed the little. What you put it in. And the order of the steps are slightly different because you're starting with the titration information and doing the pipette information. Part B, you start with the pipette and end with the titration data. We won't remember. Oh, part D, it's just a right to explain your search. An explanation. I figured I'd hold off talking about part B so you don't get overwhelmed. Is that something a good plan? Okay. All right. So, here's some good news. You guys have already done part B. The good news is that you have 2 chances for the achieved. You can either show that you know how to do these calculations in part B or part C. So if you muck up part B, you get a second chance. What I'm looking for these calculations is that you can use the equations, the N equals C times V, the N equals little m over big M. Just showing that you can use those two equations. Are we okay with that? All right. I can also accept minor errors so long as it carries through. So that's the achieve requirement. So like I said, I can take it from part B or part C. So if you mucked up part B, good news is I can take it again. The other thing, here's now part C. So for part C of this assessment, I need you guys to collect titration data, and they need to fall within some sort of appropriate range. Doesn't need to be 0.3 because 0.3 is super accurate, but it needs to kind of make sense. The other thing I need for achieved is for you guys to show me you know how to do an average. So this right here, if you're just trying to aim for an achieved, is I need to see that you've collected data and averaged it. That's all. So if you muck everything else up, you're still fine for an achieved. So this is all I need for an achieved, with the requirement that you have been able to do the calculations for part B. If you haven't been able to do the calculations for part B, then I need to see it here. I'll explain. Okay, don't worry. You skip to the excellence. Miss, I don't want to hear this. All right. For the merit, I need you to get the correct number for the concentration as your final answer, either in part B or part C. So if you marked up part B, part C is another chance to show it. So basically, I'm looking for, did you get this answer in either part B or part C?
Miss, no, we muck up part B and then get like merit in part C.
Yeah.
This would be achieved.
You would get merit overall.
Even S's?
You won't be able to get excellence. You need to get it all perfect. Are we okay?
No.
I will mark your part Bs because you guys obviously look really worried, and it was actually like it's okay. All right. The other thing for that merit is that titrate volume, both for part B and part C, you need to have at 0.3 as the range. So you see how that repeats itself in both part B and C. The other thing I need for part C is that you need to be within 0.4 of my expected value. So that's what I was saying, that number. So I do the titration, I get a number, you have to be within 0.4 of my number. If you're not within 0.4, you are getting an achieved. So this is my answer, Klein. You can be 0.4 above my answer or 0.4 below my answer. And you will be able to get merit or excellence. So this is what 0.4 below is, and that is what 0.4 above is. So this is the range that I'm willing to accept for merit or excellence. So you will do your average for your darker blue paper, and if your average is within this range, you're okay. If your average is not within that range, you need to come in on Friday and practice titrations. Okay? We'll be in session 1 for chemistry. Okay? Sorry. All right, so that is for the merit. Excellence is actually really easy in comparison. Excellence, you need to meet the merit requirements. You need to pass both part B and part C for the excellence. So if you mucked up B, I'm sorry, your grade's going to be a merit. I will mark your stuff. I will let you know where you are, okay? So you guys are worried.
Oh my God.
All right. The other thing that I am looking for excellence is that for the questions that say 3 significant figures and units, that you have 3 significant figures and units. If you forgot to do that, you're not on track for excellence. Okay? Keep in mind that these assessments are holistic, so if you forgot to put the units down for one of your calculations, I'm not going to mark you down for a merit just for that. But if there's lots of repeated mistakes, I have to mark you down. Does that make sense?
Yeah.
Okay? So that is part C calculations. It's just like part B, just working in a slightly different order. What questions do you have? I will mark part B soon. I haven't gotten around to it. I'll put the grades on Google Classroom or something so you guys know if you have it or not. Huh? I haven't marked part B yet. I just said that. I haven't gotten around to marking part B. I will try to do it soon. I will put the grades on Google Classroom so you guys don't have to worry anymore. Okay? Take your time. The good news is if you mucked up part B, you can still get a merit. But you won't get excellence. Okay? All right. Guys are so worried. Okay. So what I want you guys to do for the remainder of this period is to practice these calculations on the darker blue paper with your data. I will also give you a packet of Part C style assessment questions so you can practice doing the math. Okay? I don't know if I have any more dark blue, but you can always do it on a light blue piece of paper and just write that it's your data. Okay? So there's plenty of light blue. All right, I'll put that up on the board.